Hi, welcome to Bear Mountain. Well, today's video is about, well, a repair or a replacement in this case for our cooler. We had a good hot spat of weather this summer, and our air conditioner that we use with our CoolBot in our cooler finally fried itself this last week, and so we had to go get a replacement. And what we are going to show you today is just a little bit of some of the steps we went through. We've got some work to do on this cooler this winter. Obviously some inside siding and painting needs to be redone. This cooler is about 12 years old now, and so it's performed pretty admirably. We typically get about 3 to 4 years of continuous use out of an AC unit. This last one had some issues, I'm not sure why, but it only lasted us about 2.5 years instead. This new unit is the next iteration of a Frigidaire. It seems the Frigidaire for us has worked the best. This is a 12,000 BTU unit, runs off of a regular 115 volt AC. And what you're looking at is the actual replaced unit itself. We have a rough cut hole in it, the wall that's roughly about 16 inches in height and about 22 inches in width. So what we try to do is we place the unit inside that, and then we pack around it, and we have hold down bolts on the top, on the inside, and a bracket on the outside that keeps the unit balanced. The CoolBot is what we use to control it. You can see the temperature in the room right now is 67. And when we turn this thing on, we're at a point we're going to turn on here, we're going to check the compressor, and because we're due for some really hot weather here in the next few days. And so everything is wired up. We have the sensor from the air conditioner unit itself. When you buy it and you pull off the front grate, you'll notice it's usually right here. StoreItCold.com has great videos on how to put the CoolBot, hook it up, so I'm not going to go too much into that. But the heat sensor, which comes from the CoolBot, heats the sensor to the air conditioner. And the basics of this is it's a programmable logic controller, which you set the temperature for the room. We want it to be 37. That's where we're ultimately going to get to. And the room temperature is at 66 right now. So this thing will run, and the CoolBot will cycle on and off to keep it until finally the room gets down to its set temperature. So the CoolBot controls the air conditioner. The controls in the air conditioner you set to the lowest possible, in which case most of these guys are 60 degrees. And so it's set to that. And you put the fan on high, don't put it on auto. And basically at that point there are no other setups to do on the actual air conditioner itself other than make sure your outside vent is closed. And this guy will run it from this point forward. So once you turn on the air conditioner, the CoolBot will keep working on turning on and off the heater, which keeps the condenser turning on and off. This thing is designed so that the coils themselves don't freeze up. When they start to freeze up, the sensor in here sends a message back to the CoolBot, and the CoolBot turns off the heater, and so it actually allows the condenser coils to basically thaw out. And this cycle just repeats itself over and over. This lead wire right here is actually a temperature gauge for the room itself, and that's displayed all the time on that. We keep this thing running 24/7 during the season, and so there's a lot of hours put on these things. So the insulation packed around it is just basic standard foam insulation. We put a couple of hold down pieces of wood off to the side, and the hold down brackets as we talked about on the top. So we'll go outside and take a look at what it looks like from the outside. Okay, the air conditioner itself, like I said, goes through the opening in the wall, and you may notice, you go, wow, it looks like it's a little canted on, you know, like the outside edge is canted down, and that's exactly what we want to do, because as the condenser runs and pulls heat out of the inside of the unit, it's going to get moisture condensation, and there's actually a pan at the bottom of this outside coil which collects that water, and then there is a basically drain opening in the bottom which allows it to drip out. One of the last things we'll do after we finish all the flashing around the outside of this is we will get a just a regular like little tubing. You can get it at Home Depot or something like that. We'll connect into this and just pin it to the wall to make sure that the water drains down and away. It's real important that you have at least a 4-degree drop, and that's about what this is. And that keeps the water from flowing backwards inside, because we've had that problem before where we didn't have the angle right and we didn't realize it, and you ended up with some water dripping down the wall. And so that is something that's real important. So this bracket is designed to basically give it extra support. It is really resting on it from the inside here, and it rests against the wall itself. So this thing can hold 160 pounds, and the air conditioner unit we're using at 12,000 BTU is only 70 pounds, so we've got more than enough room. The last thing we'll do is put some flashing over the top to shunt any water that comes down off to the side. We will seal up the foam here and paint the outside wall, and everything should be good. The painting of the wall is really something, the shed, like we've said, we've used this cooler now since 2005, so she's due for a painting anyway. Anyway, the last thing to note on here is that you got to be really careful on these fins on the outside, and we'll come around and take a look at those. Now, one of the things that you may notice is that some of these fins got a little crunched. This is airflow is going out, and this is a way that the heat, basically the heat exchanger, the condenser works. The heat flows out this way, and some of these got crunched. When we pulled it out of the box, we noticed that, and they were crunched from shipping. And so what we're going to do is we'll just take basically a very small screwdriver and push them back out so that they're open and straight like the rest of them. And we have a little bit of a problem here on this side as well. We didn't notice any of that on the inside, so I think we were in pretty good shape. We'll use some spray foam around the edges where we can't get any insulation, hard insulation into there, and we'll put some flashing on the bottom here too, just as an extra measure. So let's go back inside and fire this bad boy up and see how it runs. And now we're ready to plug in the cool bot and test the unit to see if it's going to get us cool. The room in here right now, we don't know for sure, but as soon as we plug in the cool bot, it's going to tell us what the temp is, and we'll see that thing come to life here in a second. At least it should have. There she goes. Students diagnostics check, and it's 72 in the room. Okay, the next step is we turn the air conditioner on. We make sure that it's set to the lowest possible setting, which is 60 degrees. And we make sure the fan speed's on high. And we change the mode to cool. Not economy. Economy will automatically switch it on and off, and you don't want to do it. You want it on cool. Now, as you can see, what's happening is the room is warming up. That's because we're in here and we have a light on, so it's going to take a minute or two for the condenser to kick in. Okay, well, it's been running about a little less than 20 minutes now, and it looks like it's working from below 60 degrees, flipping between 56 and 57, and the heater unit is still on. I can feel it on the temperature sensor here, and we're getting no freezing up, and the condenser is still running when we're below 60, so that pretty much tells us the cool bot is in control. Like I said, it took about 20 minutes. We dropped from about 73, 74 degrees down to the 57, 56, or 56 now, and as we get 20 more degrees down to our set point, it's going to take a little bit longer for every degree to drop. So to get this thing to the point where we're ready to put flowers in, it'll be ready by tomorrow morning. It'll be in perfect shape. So, disaster averted. We're still able to go out and harvest, get stuff into the cooler here starting tomorrow morning, and things should be in pretty good shape. Just want to say one last thing. These are regular stock off-the-shelf air conditioners. You can get them at Lowe's and Home Depot. They cost, this small costs about $350. storecold.com, and they cost somewhere in the neighborhood. When I bought this last one, I think it was like $280 or $290 per unit. And in some cases, some people, this is what veggie people are doing, and just as a thought, if you need bigger space and you need to get the temperatures down faster, what veggie people have done is they've actually ganged two of them up in the same cooler. So either way, what you're looking at is $600 for a 2-unit, or for a unit setup. So, you know, basically $1,200 to do your entire cooler is, you know, you could probably do a cooler. This one's 10 by 10, but you could probably easily do something 10 by 20 and cool it down really rapidly. Or you can go with a larger unit. This is still running on 115 volt. You can go to larger units once you get above, say, 15,000 BTU. You would be, you know, a lot more capacity, and it would cool a larger room. So anyway, great information on storecold.com on the CoolBot. And if you like what you see, please subscribe to us. We have our subscription button at the end of the video up top. Also, too, you may notice some links down at the bottom to other videos, either our most recent or other ones that kind of fit along with this. And I want to thank you for watching.